We are exploring the world of cryptography in this series of lessons, and you have already been introduced to the scissor cipher, but it's been a while, so I'm just gonna recap what the scissor cipher is and pull it back into the more big picture overview of cryptography, and we are gonna code our program to do encryption and decryption on the Caesar cipher in Python, and it's Caesar cipher is uh, one of the simpler um, encryption methods to code for, which is great because then it gives us a chance to kind of focus on the different coding concepts um, that are used to build this program. And as we explore other ciphers later on, you're going to be using the same concepts, right? And it's going to just get a little bit more complicated. So we're going to start easy with the Caesar cipher, right? So cryptography, why cryptography? What is the need for cryptography? Um, Imagine that you have a secret. You want to tell a friend a secret. You don't want anyone else to know. Uh, what you do. You write it down on a small piece of paper. Um, you pass it to your friend. You make sure no one else sees the message. But what if you can't pass it to your friend directly, right? Your friend is far away. You have to use some channel of communications to pass the message to your friend. It might be that you have to shout it at your friend. It might be that you have to kind of ask someone to deliver it to your friend, to deliver the message to your friend. And so when that happens, what happens is that the message is going to leave your hands. It's going to be held by other people, and so you have to trust them, right? Not to snoop on your message, and sometimes they might, um, and so the other thing you can do is then to encrypt your message, right? So that it's no longer in readable, it's no longer readable by a casual observer, and that means that they may see the contents of your message, but they won't understand what it means, and that's cryptography basically. It's kind of hard to sort of find a reason for us to use to cryptography, because we don't really have secrets that we don't want anyone else to know. Um, but one of the biggest users of cryptography is in the military, right? So you have opposing forces, um, and information is really crucial. For example, if you have a message that you want to disseminate to your allies, saying like, "Hey, let's attack tomorrow at dawn," right? And if you have the element of surprise, um, then your attack will be more successful, right? You catch your enemies off guard. They are not ready for you. Their forces are in disarray. There's a bigger chance of you winning the battle. But if your enemy gets wind of your message, then what's going to happen? They're going to have time to prepare. They know where you're coming from. They know what time you're going to be attacking. So they're going to be on high alert at that point in time. And so that's bad for you. So I mean, it's a life and death kind of situation, right? More lives are going to be lost, and so cryptography is really important in the military. Um, that's an obvious, use of cryptography. But we actually use cryptography in our daily lives. We may not be aware of it. For example, your email. When you retrieve your email, when you log in into Gmail, for instance, you type in your password. Your password gets sent to Google servers. You never know if anyone is going to be snooping on your communication along the way on the internet. A man in the middle attack, a compromised router, um, wherever you have it. You don't want your password to be seen by people along the way, right? So you want to be able to encrypt sensitive information such as those, right? And that's where cryptography is being used in the computing world. Okay. So yeah, so Caesar cipher, this is an example of a message that has been encrypted. So a casual observer is going to look at this and go like, I have no idea what this is saying, right? And then they're going to give up, perhaps. They won't be able to decode your message, or they might try really hard to decode your message, but they're going to take a while. And by the time they decode the message, maybe the contents of the message is no longer useful. For instance, if you're gonna in the military, if you're gonna attack tomorrow at dawn, if they're gonna take longer than that to decode the message, then the encryption has served its purpose, right? So that's why we are interested to explore the world of cryptography. Okay, so back to this, the coding of Caesar cipher. I'm gonna try to step by step build the Caesar cipher program in Python, and I want you to really focus on understanding the code, and also focus on how we build the code up, because you're gonna be using the exact same coding concepts. You're gonna be using the exact same process in order to implement your own encryption, right? When we explore other ciphers. Okay, so firstly, we want to encode a message. We have to have the message that you want to encode, and I'm going to store that inside a variable, and I'm going to call the variable plain text, right? And so our message is going to be the quick brown fox jumps over the lazy dog, right? I just chose this sentence because it uses, I think, every single letter of the alphabet. So it's a good way to ensure that every single letter is going to be encrypted and there's no bugs, right? So the key to cryptography is that between you and the intended recipient of the message, you are sharing a secret, right? And that secret only both of you know, no one else knows. And that secret is key to encrypting and decrypting the message. If anyone else knows the key, they will be able to read your message. They'll be able to decrypt the message, right? So it's a secret. In the case of the Caesar cipher, the secret is essentially how many spaces are we going to shift the character, right? So I'm gonna choose a random secret here. I'm gonna call it key. Let's say we are gonna our secret is gonna be 2. So what this means in the Caesar cipher algorithm is that the letter T, okay, is going to shift it by 2. So it's going to be QISTUV, right? So T is going to become V. So the output is going to be V. The letter H is going to be shifted by 2. A, B, C, D, E, F, G, H, I, J, right? So H is going to be shifted to J. E is going to be shifted to A, B, C, D, E, F, G, right? So E is going to be shifted to G. For non-alphabet characters, like a space, we are going to skip over it. Q is going to be shifted over to P, Q, R, S. It's going to be shifted to S, and so on and so forth, right? So the secret is the key, and the key is the number of times that we are going to shift the character. And I'm going to choose 2 for Pierre, and I'm going to make sure that my friend who's going to receive this message also knows that the key is 2, right? So after we encrypt the message, we will get the encrypted message, and I'm gonna store it. I'm gonna store it in this variable, and right now the variable is gonna be the empty string, but we are gonna build this sentence up, the encryption up, character by character, right? So what we need to do is we will need to go through every single character in our message, in our plain text message, right? So when we need to do something like that, we need to go through every single character in order. We are going to use your concept of iteration, of loops, right? And in Python, the syntax for loops will be for something and something. For what is the first one is going to be a variable that you define. So the name of the variable, I'm gonna name it C, right? It could be named anything. but I'm gonna name my variable C just for conciseness, and so it's gonna be for something for C in what is the sentence, what is the list sentence that we wanna go through, and that's gonna be the plain text variable which contains our sentence. And then I need to have an indentation, right? That's the spaces here that you see, so that we know that we're in the body of this loop. And just for the first iteration, I'm just going to print out the characters. Right? I'm going to print out the variable C so that you will know, what's happened, how the loop works. So let's run this. Save it, and then we'll see the output on the left. Right? So you can see what happens is that it's going to print out every single character. The print statement adds in a new line character. So that's why it appears vertically rather than horizontally, because the print statement prints out, inserts a new line character. But what you can see is that the variable C here, takes on every character. It first takes on T, and then H, and then E, and then space, and then Q, and then U, and then I, and so on and so forth. Right? So we have access to every single character in our sentence, right? So then we can process every single character and shift it by by our key amount, our secret amount, and then build our ciphertext from that. I'm not gonna do that yet. I'm not gonna shift that yet. Instead, I'm gonna build our ciphertext first, right? So what I'm gonna do is I'm gonna say that for every single character in the plain text, our ciphertext will be equal to, we are gonna add our character into the ciphertext. This is shorthand. I'm gonna do what it means. It's gonna look like this, right? This is what it looks like. I'm gonna take our existing ciphertext string. I'm gonna append our C character to the end of it, okay, using the add operator. And when you're adding two strings together in Python, it's gonna combine them together. Okay, and I'm gonna store the result of this operation back into the ciphertext variable. So it's gonna update the ciphertext variable, right? And I'm gonna print. Notice that I'm not indenting this line because it's not part of the for loop. It's after the for loop. Right? I'm gonna look at what the ciphertext looks like at the end of going through the entire loop. Right? So let's save this and let's run the module. And you can see that what's the output? The ciphertext will be exactly the same as the plain text because we did not process the characters. Right? I'm gonna just add another sentence here, another statement here, so that you know what's happening as we go through this for loop. What does the ciphertext contain, in each run of the loop, right? This is just for educational purposes for us to see what is happening. So let's run the module. Let's see what happens. Yeah. So look at that. That sentence is being built up character by character. The ciphertext variable, every time you run it, you're adding the next character into the ciphertext. Okay, so that's we don't need to see it. I mean, it's kind of fun to look at, but yeah, we don't need it. Okay, so now we'll do the encryption. Oh, sorry. Before that, I just want to say that this algorithm, right? This steps is gonna be a common. You're gonna have to be doing something similar for everything for the other ciphers that we are going to be working on, right? So remember this concept of using a for loop. Remember this concept of appending a character to the end of the string and then storing it back to update the original variable. So remember that because you're going to be using it. So what we're going to do next is we are going to process the C character, right? So we're going to shift it by 2. So what I'm going to do is I'm going to have like a temp character, right? I'm going to call it temp, right? And what the temp character is going to be, will be the character we are working with, and we are going to shift that character by the key amount, which is in this case right now it's 2, right? And you might be wondering how can I add a character to a number, right? This is like saying add the character, add 2 to the character t. What's going to happen there? In Python, at least when it sees that you have a character and it's a number, it's going to add it together as if it's adding 2 numbers, because this character is actually a number. We've talked about ASCII before, where you understand that every single character is actually a number, right? So big capital A is 65, small a is 97, B is 98. So when I add, for example, the first one that we have is big uppercase T, right? Uppercase T is actually 84. When you add 84 to 2, you're going to get 86, and 86 is actually V, right? Well, I hope it works. Actually, I just realized that I need to do additional functions. Okay, I'm not sure whether it works or not. I'm just going to give it a try. So over here, instead of adding C, I'm going to add a temp to it. Okay, cross our fingers. Let's see whether this works. Gosh. Okay, so you see here there's an error. It says here that can only concatenate string, not integer to a string. So actually Python is kind of confused when you're trying to add a string and a number together, right? So because of that, we are going to be using some functions to help us. And the 2 functions are the ordinal function, okay, and then the car function, right? I think so. Let's give it a try. Car function is not defined. Yes, I should have known that was not a function because it wasn't purple. It wasn't. The editor didn't recognize it as a built-in function. Okay. So something happened here. We have an output. It looks weird. That's because it's encrypted, right? Okay. So let me explain the concept of the ordinal function and the car function. Using just by printing them out, right? So instead of printing the letter C, I'm going to print the odd of C, right? And so what the ordinal function does is it takes the character and it converts it into the corresponding number in the ASCII table, from the ASCII table. Right, so let's run this module. There you go. So instead of getting the quick brown fox jumps of the fox, you're getting a bunch of numbers. So if you see T is 84, and why is it 84? If you look at the ASCII table, 84 is the big capital T. The next one is small letter H. Small letter H is 104. 104 is, there you go. From the ASCII table, you know H is 104, right? So that's the odd or ordinal function. Now, what the CHR function does is that it does the opposite mapping, right? It goes from a number to the ASCII character, right? So then what I'm doing here is that I take my character C, I turn it into the corresponding number, I add 2 to it, and then I send it back and convert it back into an ASCII character. Okay, so let me just show you when I run it again. Right, we're getting this weird thing. And I think it kind of work. It kinds of work. But what happens is that you notice that even for the space character, it got shifted by 2, right? And it became this quotation mark. And I think if you take a look at where the space character here, this is a space character. You shift it by 2, it will be the quotation mark over here, right? Double quotation mark, and that's why it appears a double quotation mark. So what happens is that we don't want to shift the alphabet characters. Sorry, what am I saying? We don't want to shift the non-alphabet characters. So we need to do a test first to check whether our character is an alphabet or not an alphabet, right? So how do we do that test? We will have to use a conditional, right? An if statement. So we'll do a check here. We'll kind of gatekeep if C is in alphabet character, right? A B C D E F G H I J K L M N O P Q R S T U V W X Y Z. Okay, and this is just for the lowest case character. We need to do it for uppercase characters too. If the character is one of this, then we'll perform the operation. Otherwise, okay, we will just append it without processing it. So let's run this, and it's not gonna work on the first character because that's a capital T, right? But it's gonna work on the others, right? H gets shifted to J, E gets shifted to G, and so on and so forth, right? So we kind of half fix it. Instead of this, actually there is a built-in Python constant that actually represents the alphabet characters. I don't remember it offhand, so I'm just going to do a Python string module constant. This is the documentation, so let's take a look at this. There you go. You have the constant will be if ASCII characters, ASCII lowercase, ASCII uppercase, digit, hex, punctuation, white space, printable, ASCII letters. That's what we want, right? It will contain A to Z lowercase and A to Z uppercase, right? So let's try that. Let's see whether it works. I might have to import the string module. Does it complain? Yeah, okay. So let's import the string module here. There you go, right? So we got the same result as before, but we didn't have to define the alphabets A to Z manually. It's built in for us, and as an added bonus, it also includes the uppercase. So now you see the letter T, it's also the uppercase T is also shifted. Right, so we are here. There's one more thing we need to do. If you notice, and that's why we chose a sentence, the quick brown fox jumps over the lazy dog, because it's gonna then operate on all the characters of the alphabet from A to Z. You'll notice that there's something weird here, right? This is corresponding to the word lazy. This is the letter Z, this is the letter Y. You'll notice that it became non-ASCII letters, right? It became non-alphabet letters, right? And that's because if you take a look at the ASCII table, here is Z and here is Y, right? They are towards the end. What happens is that, let's look at Z, it's 1 to 2, and you add 2 to it, it becomes 1 to 4, and 1 to 4 is the pipe character. You look at Y is 1 to 1, you shift it by 2, it becomes 1 to 3, and 1 to 3 is the curly brace. So that's why you see the pipe character and the curly brace here. And we don't want that. What we want to do is that if the character has reached the end of the alphabet, you want to actually have it go up to the top, right? So what happens is that Z is going to shift it towards A, B, right? If you shift by 2, it will shift to A and then B, right? So Z will be shifted to B, Y will be shifted to ZA, Y will be shifted to A, right? That is the scissor cipher here. Right? So this one, it's the secret is 3. Here, X will be shifted to A, Y will be shifted to B, Z is shifted to C, right? So it's supposed to go back onto itself. It's not supposed to bleed into your non-alphabet characters that you see here, right? So that means we need to fix our code, and there's a slight uh, complication here because there are two sets of alphabets. There's your uppercase alphabet and there's your lowercase alphabet. And so just to make things not so complicated, I'm just going to work just purely in the lowercase characters first, right? And then making it work on both upper and lower. That's going to be a bigger exercise, right? It's going to be a more complicated exercise, right? So what happens is that, right, so we know it's an SQL character. We are going to perform the shift to it, and what we're going to do is we're going to do a check. We're going to have a check if we add a key to our character. If we add the key to the character, and we'll check if it goes beyond 1 to 2, right? What we want to do is then we want to shift it back to the top, right? We want to shift it back to the top. So we could say, for instance, if temp is more than the last character of the alphabet, right? Instead of I could say 1 to 2, but just so that you understand, other people when they read this code, they understand why are you checking for beyond 1 to 2, right? So I'm just gonna say beyond the last character of the alphabet, which means the ordinal number of the character Z. Then I am going to remove 26 characters, 26 from it, right? So then it will shift to the top. Okay, right? Y minus 26. What happens is that this character here, you can imagine that I can actually transpose it back to the top, and that will be 26 characters off, right? So that's what I do. Okay, right. So we have this. Let's run it, and we'll see whether it works or not. Oh, right. Sorry, Z is not a variable. I need to put it in quotation marks. Can only concatenate string. Yes. And I will need to change this back to character. Right, this is a normal part of debugging. Read the error message and then try to figure out what the error message is saying to figure out what's wrong with your code. So now take a look at our output here. You'll notice that now Z, the character Z, instead of the pipe character, is now maps to B. The character Y now maps to A, and that's exactly what we need to do. Let's change our key. Let's say key is 5. Does it look right? I think so, yeah. So now we are able to change our plain text into different messages, into different encryptions by using a different key. And as long as you and your intended recipient knows what that key is, you can encode it in that key, and your recipient can decode it using the same key, secret key, and they will be able to read the message in plain text.